All right. Hi, everybody. I'm Matt. I'm the developer of Ref, which is a documentation search MCP server. Super excited to be here with y'all. Thank you to the Stytch folks and the Outpick folks for bringing us together, and the pizza and the beer. That's awesome. If you haven't heard of Ref, like I said, it's a documentation search MCP server. So imagine your coding agent never made mistakes working with libraries, either public libraries or private libraries. And in particular, it's able to do that without blowing up the context window. So it's able to find just the snippet of documentation it needs to be successful without bringing in a bunch of other crap into the context window. That's what Ref's built to do. My goal for this talk, I have a couple goals. The first one is that I hope you learn a little bit about search and search evaluation, especially in the context of agents. Then I'm going to go through a little demo of what it's like to use Ref actually in practice. And then I'm going to go through some of the numbers from our evaluation. And I might have a request for you all at the end. How's that sound? Thumbs up? Cool. All right, there's a lot of thumbs. Great, let's do it. All right, so I'm sharing the wrong screen. 1 second. There we go. All right, that's what I want to show. So search. The classic search problem is you have a query and you have a bunch of documents, and you want to find the documents that are relevant to the query. That's typically evaluated with two metrics, precision and recall. Recall refers to, did we find all the documents that were relevant? And precision refers to, of the documents we returned, which ones are relevant and which ones are not relevant. So your perfect search is you found all the relevant documents and you've returned no irrelevant documents. Everything's relevant. That's sort of the classic one query set of documents search with a search API. But at Ref, we're building a search system for agents. So instead of using recall and precision, we use recall and token usage. The reason for that is that we want to evaluate the entire agentic search process. So rather than evaluating a single call, we want to evaluate the entire process the agent goes through to find what it's looking for. And agents search just like humans. They do a search, they refine their query, they open a page, they realize it wasn't the right thing, they fall back, they open up another page. Eventually, when they're done with what they're looking for, they're done, and then they move on with their task. You can see this if you just watch Cloud Code or Cursor work as it searches and then it has what it needs and it moves forward. You can also see this from OpenAI. They're waving a big red flag that they're training the models to do this. The deep research spec, if you want an MCP server to connect to ChatGPT, it needs a search and a fetch tool, just like this search and read pattern. The reason we choose token usage to evaluate this entire loop is the agent has this finite and precious resource, which is the context window. The context window is precious for a couple reasons I think we may be aware of, but the first one is that inference is expensive. Tokens cost money. If you're just putting a bunch of stuff in your context window, you're just paying for that for basically no reason. And the second reason the context window is precious is for context rot. The team at ChromaDB had a paper over the summer about this, where they showed that even the frontier models, as you just put more stuff in the context window, the quality of output degrades. This means when you're throwing a bunch of extra stuff in your context window you don't need, the quality of your outputs gets worse. That's kind of the experience you have when you're in Cloud Code and you're working for a while, and eventually you get to this point where you're like, I gotta throw it away, and you have to restart. Like that, context rot is one of the things that contributes to that, where you just know it's never gonna come back. So that's what we're building Ref to do. Ref is built to find the piece of documentation you need while using as little of the context window as possible. Let me jump into the demo. Oh, no, that's the exciting part later. Let's go to the demo. Quickly, I'll show, there's like an app for Ref, so you can have a team and build a shared private index of documentation with PDFs and private markdown files and indexing your private repos and stuff. It'll index code and docs. But that's the less exciting part. The cool part is actually seeing, what's going on, Clyde? Seeing it in action. Let's see. All right. Yeah, so seeing it in action. The way you're going to use Ref, there's a couple ways. It's an MCP server, so you're going to use it with your coding agent. There's kind of two ways it'll show up for you. The first one is the more magical one, where it's in the background. Your agent encounters some lint error or some error related to a library, and it realizes, I need to go check the docs. It goes and checks the docs, finds what it needs, and moves on. Kind of, you might not even notice it did it. It just happens in the background, and it doesn't make a mistake it would have made otherwise. The other way you'll use it is in a more active way. So the way I do this myself is I have a Cloud MD where I say, when you're working with libraries, search for docs with ref. But ref also provides tools to guide you to prompt towards this. But let me just quickly show the MCP server itself. So we're connected to ref here. We can look at the tools. The two tools ref provides are the search documentation tool, which will search the web and GitHub for documentation and return URLs with a description of what's at that page. And then the read URL will allow the agent to read that page, the full content into context. It can also scrape pages on the fly. So sometimes documentation will include a link to a page that's not indexed in ref. So we have that capability to follow that link. Yeah, so let's go on to the demo. I mentioned before that when you're actively working with ref, you might want to guide it to say, hey, you are working on a task right now that's going to involve a library. I want you to make sure you check the docs. So ref provides over MCP 2 prompts, one to guide ref to search, or guide the agent to use ref to search public docs, and one to search your team's private documentation. So we'll go ahead and do a public doc task. Write a script in Python to list and drop namespaces from TurboPuffer. So kind of your classic sort of coding task here. We'll give it to Claude. It's doing a search, and it got some results. Let's see where it goes from here. It's doing another search. Gonna read some URLs, and great, it has everything it needs. But let's look at what it actually did here. So a couple of things I want to point out. Each one of these searches, this one returned 5, and I think this one returned, well, they both returned 5. Well, one thing that doesn't show up in this demo, but ref does, is it is adaptive in the number of results it returns. So a classic search API comes with a query parameter and like give me n results with a default of like 10 or something, or a default number of tokens to return. But that's kind of a weird concern for the agent to have, because like, how does the agent know? So like, how does it know how many results it actually wants? The search server should make that choice. So ref will, for specific queries, return fewer documents, and for more general queries, return a larger list. Something else I'll point out here is this this code tab. This is not part of TurboPuffer's documentation. This is something ref's crawler has added through crawling the page. One thing you'll notice if you ever try to use something that scrapes a page of documentation, it will typically scrape the top tab, so you'll get the curl instead of the Python or the Go or whatever have you. That's one of the things that ref's web crawler does particularly well, is it actually knows how to read documentation pages. And we found the right code tab. So we found the Python pages. And so we see here, it's instead of pulling a sort of classic RAG would have taken all of these documents, put the entire document, and let the model sort of sort it out. In this case, we just have descriptions, and we see Claude has chosen to read the namespace, the get namespaces, and the delete namespaces APIs for Python. So we can zoom into these docs a little bit. You can see here we have basically exactly what we need. We have the code snippet, we have the explanation of the API, and that's it. That's all we got. That's all we needed. We just gave it the piece of information it needed. I want to also say none of this is synthesized. This is all the source of truth just scraped directly from the website. And ref has found just the exact piece we need. And we can feel, at this point, pretty confident that Claude is going to be successful now that it has the 2 APIs it needs with the exact docs in context with nothing else in there. Cool, and that's how you would use ref in practice. Let me go back to the talk, and we'll talk about the evaluation metrics. So I said in the beginning, we evaluate ref in terms of recall and token usage. For token usage, the way we do that evaluation is we set a baseline of 10,000 tokens, and we evaluate what percent do we save. So we set the baseline to have a normalized score out of 100%. What percent of tokens are we saving? The reason we choose 10,000 is there's another very popular MCP server in this space called Context 7. The way it works is the more classic RAG approach, where you take a library, you grab a bunch of stuff, you put it in context, and it uses about 10,000 tokens per request. It's a very popular server, so it's an interesting benchmark to set to say how much better than this popular server can we do. It turns out we can do pretty significantly better. In the average case in our eval, there's a 50 to 70% savings, sort of depending on the query. All the queries in the eval set were taken from real queries that people are making for popular libraries. All of them came in under the 10,000 tokens, and on average, you're saving like 5,000 to 7,000 tokens. In the best case, 95%. So that's the 500 tokens that matter instead of 10,000 tokens of not very relevant stuff. That has pretty obvious impacts both on cost and on context rot. That's what makes Ref special. That's why I'm building it, to solve this specific problem. And that's why thousands of developers every week are adopting Ref so that their coding agents make fewer mistakes. Cool. And that's Ref. This QR code has a few things at it. It has my socials. I'm a solo developer. I know I said we a lot in this talk, but it's because I have a hard time taking credit for my work, but it is all my work. I'm a solo developer just trying to build the best version of this piece of software. So a thing that's really valuable to me is just any amount of engagement, getting the word out. So my socials are there. If you're interested in how some of this is implemented, the blog and the docs are there. And there's a sign-up link if you want to try it out. So yeah, thank you all so much. Really appreciate your time.